Hello, this is Jamie from CSIRO's Australia Telescope Compact Array. In this tutorial video, I'll show you the applications you'll need to use while observing with the ATCA. By the end of this video, you should be able to identify all the major monitor and control applications and what they're used for. We're not going to get into much detail here though, that will be covered in later videos. Two applications are used to control the ATCA, CA-OBS and CA-Core. We'll first look at CA-OBS, which is the window that we've highlighted here. CA-OBS' main job is to execute the schedules you make, and it's what you'll use to do a lot of the array setup before and during your observations. It also conveys a lot of useful information. It has two clocks, one showing universal time and the other showing the sidereal time. The current source being observed is shown here in the top left, and the frequency configuration just below that. The progress through the schedule is shown a little further down, as is the name of the currently loaded schedule file. There are a couple of lines showing the state of the array's antennas, and there are three small sections below this information. The top one shows responses to recent events, so it's a really good idea to keep an eye on this section throughout your observations. The middle section updates every time the array starts to move to a new position, and will tell you how long it will take for the telescope to slew there. The bottom section is where you issue commands. You'll spend a lot of your time at the start of an observation typing here. The second control application is CA-Core, which is shown here in the CA-CCC1 VNC screen. CA-Core is used when you need to control the cab correlator. Most of the time, CA-OBS will control the correlator as required, but you will generally need to manually control the online correlator calibration that you'll do at the beginning of your observations. You'll do that by entering commands into the command entry box at the bottom of the CA-Core window, although it's also possible to make CA-OBS put commands into this entry box. The commands will often output status messages, and these will appear in the log panel just above the command box. The rest of the window provides a lot of information about the correlator state. At the top, we have the cycle time in seconds, and just below that we can see the name of the file the data is being written to. You'll need these files for offline data reduction, so take note of the file names that are shown here. A bit lower down, we can see a line that shows the state of the attenuator servoing mechanism, which is actually a button to enable and disable the servo. We can also see the delay calculation averaging width, and the TV channel ranges for each of the two bands currently being used. This top panel can show a lot of different information depending on the tab selected. During calibration, the Samplers tab is used to ensure the signal levels coming from each of the antennas are consistent, and we can see here the cab attenuator settings. The F1 and F2 data link tabs show information about the health of the individual digitizer input blocks, and this can be handy for debugging problems with the correlator. The TSYS tab shows the system temperature for each polarization and band on each antenna, and is a handy way to see if the calibration of the array has been successful. To inspect the raw data coming from the correlator, we use SPD, which is shown here. SPD consists of two windows, a pgplot window that displays the spectra, and a terminal which is used to control which spectra are displayed. After every correlator cycle, SPD displays the spectra the correlator has just computed, but it doesn't have any way of showing what the data looked like in the past. To see how the data has changed over time, we use Viz, which, like SPD, consists of two windows, a display and a controlling terminal. Viz can show a lot of different parameters, but for most of the time you'll want it to show amplitude, phase, and delay as a function of time. Viz will display one amplitude, phase, and delay point for each combination of baseline, polarization, and IF for each correlator cycle. Viz is most useful for quickly checking that the visibilities are consistent with your expectations. You may also be alerted to problems with your observations by the Assistance application. The Assistance window has three panels. The top panel gives some summary information about the current scan, while the middle panel gives a summary of any errors that have been detected with the system or with the data. If there are errors, the bottom panel will give a bit more detail about which antenna or baselines are responsible for them. Assistance will also beep at you after every correlator cycle if an error state exists, to let you know something is wrong. Another useful monitoring application is CA-Tag. This application computes pointing corrections if you've asked for a point scan in the schedule, but it continuously updates even if you aren't doing a pointing correction and shows, for each correlator cycle, the source being observed, the start time of the cycle, and which antennas were on source for that cycle. Here, antennas 1 to 6 are represented from left to right. A dot or a lowercase x means the antenna was on source, a capital X means it wasn't, and at the end of a pointing scan, it will display the offsets it has calculated in azimuth and elevation for each antenna. To get a quick idea of where the antennas are pointing, you'll want to use the AT-DriveMon application. It updates several times per second with the azimuth and elevation of each antenna, along with how far each antenna is away from where it should be. It also shows the state of each antenna, and a little icon showing very roughly where it's pointing. If you want to see even more detail about what the array is doing, you'll want to use Monica. The Monica application has a wealth of information about almost all the systems used at the ATCA. It can tell you the state of each system, and if any of the values it shows might indicate a problem. During normal observations, you'll use Monica to tell you about the weather conditions at the observatory, the state of the power supply, and whether you've remembered to focus the antennas. But if you do run into trouble, Monica can help you debug what's gone wrong. Well, that's the end of this video. We hope that it has helped you to recognize each of the applications you'll be using while observing with the ATCA. If you've got any questions, please feel free to talk to your observing friend or observatory staff. Good luck.